Okay, so our first optimization problem deals with money. A pretty simple one. We'll talk about revenue. There's a lot more to this story than what meets the eye, but we'll basically start there. Again, remember what we're trying to do is find a max or a min, and what's nice about 4.4 is everything is quadratic. So reading number one, we have a team of market researchers for algebra concepts determine that the company has a revenue function r of x equals negative 2x squared plus 1700x. They also determine that the company has a cost function of 40x plus 100. And x is the number of packages made, and r of x and c of x are in dollars. All right, and so the first thing we're being asked to do is to find a profit function. So this is one of those examples where there are some functions given to us, but the thing that we eventually want to maximize or minimize isn't given. So we know, or hopefully you guys should know, profit is made by taking whatever revenue I've got coming in and subtracting my cost. Right? That's a typical situation for profit. So money coming in, take away the money that we're using, and then that makes us earn our profit. Of course, we hope the revenue is higher than the cost because I've truly earned a profit. If my cost is higher than my revenue, then I'm operating at a loss. Okay? And so for this particular situation, our revenue function is negative 2x squared plus 1700x, and we're going to subtract our cost function 40x plus 100. So we basically have r of x minus c of x to get our p of x. And so our p of x then, if we do the math here, we're definitely going to get a negative 2x squared. We're going to have a 1700x minus a 40x minus a 100. So I think when we do all that, we get a positive, what's that going to be? 1660x, right? And then minus 100. So there is our profit function. So we now have a quadratic with the lead coefficient that's negative. So later on, we do in fact know that this is heading downwards, okay? And so there is actually a max or min, but I'm getting ahead of myself. So there you go. So profit is revenue minus cost. They gave me the revenue function. They gave me the cost function. We just basically subtract them, and we're good to go. Let me make sure I subtracted right? So 0, 6, yep, 1660. Okay? So the next thing they want us to do is figure out how much profit is made for 30 packages. So functionally, they're asking me to find P of 30. And so just plugging that in, we get negative 230 squared, right, plus 1600 times 30 minus 100. And so I believe 30 squared, that's 900. And right here we got a couple of zeros, actually 3 zeros. 30 times 6 is 8, carry the 4. And we get 7,800 and then minus 100. So carrying on here, we get negative 1,800. If we subtract 100 from this, this is a positive 7,900. And then if we subtract that, of course, if you guys want to use your calculators, you obviously can, 00167. So it looks like we get $76,100. Okay, so basically this says under this model, if my we make and sell 30 packages, my profit will be $76,000. All right, and so that is basically how we use our model. The next question asks us to find the number of packages needed to maximize the profits. Well, as I've told you guys, our profit function is quadratic, so basically this comes down to finding the vertex, right? So where's x? And somewhere over here is the maximum value of p of x. So we basically have to find the x coordinate of that vertex, so the number of packages. So using the vertex formula, we know that x amount, right, is negative b over 2a. So we have negative 1660 all over 2 and a negative 2. A negative divided by a negative is a positive, so we basically have 1660 over 4. So doing a little bit of math here, right, we get 4 and 1 and 15. So it looks like x equals 415. Okay, so in order to get a maximum profit, we would have to basically sell and make and sell 415 packages. And then the next question is asking, what is the amount of profit? Well, we know that if I know the x coordinate, right, for my vertex, we basically just have to find the y coordinate at that value. And I am going to bust a calculator at this time. So we have -2, 415 squared, what is that, plus 1660 times 415, and then minus 100. Okay, so unfortunately my TI calculator is a little, again, it's giving me some problems. I'm wondering if there's something electronically wrong, but if I do this first one, I'm just using my calculator on my computer. If I take 415 and I square it and then multiply it by -2, I end up with a negative 344,450. If I now take 1660 and multiply it to 415, my calculator is giving me 688,900, and then minus 100. So if I now take all these numbers, I take the 688, I subtract the 344,450, and then I subtract the 100. What I'm getting from my calculations is $344,350, $344,350, okay, or $344,350. So that is basically what's going to max. So if we were to graph this, the 415 would be the x value, and 344,350 would be the corresponding y value. We would definitely have to mess around with our picture window in order to see that real accurately. But there is your first optimization problem. In this one, we had to build the function. Once I had the function, we can analyze it, right, and then we can definitely maximize it. We had a nice, easy, well, I wouldn't say easy, the numbers are pretty big, but we had a nice vertex to find, and we know how to find the vertex. In this case, I used the vertex formula because I'm not too sadistic, all right? We could have used the whatchamacallit, oops, I think I made a mistake up here as well. I think that was 1660 as I'm looking at it, which would have changed that number, which would change that number, but I'm not going to bother. I think you guys get the point. I apologize. I used 1600 instead of 1660, it looks like. So just be careful, all right? Watch your numbers. As you can see, I made a mistake, but hopefully you guys get the big idea. That's a classic situation. We'll do another one here shortly, and we'll see some nuances in that one. Talk to you guys in a moment.